Hello. Part of the problem was, anybody who's run a panel, there's a little trick to this. You basically set a whole pile of questions and you show it to the delegates beforehand. And I'd set all these questions thinking, right, these are all the things I need to cover, and it's going to be great. And they've all been covered today in various shapes or forms. You know, this conversation we're going to have really is kind of more of a reflection on what you've heard today. As I ask questions, you can introduce yourselves, basically, but engineering today, Emma. What does it mean to be an engineer right now, today?
Wow, great start, Tara. So look, first of all, really well done to all of the speakers. This is going to be the easiest panel I've ever sat on because everyone, I think, has answered all of Tara's questions already today. My name is Emma Pollock. I am a Chief Technology Officer. I've got about 20 years in the technology field, primarily in financial services and capital markets. What does it mean to be an engineer today, Tara? It is a big question. And when we prepared for this panel, we talked a little bit about this, and I think people say engineer and they mean different things. I have a very simple definition for it. An engineer is someone who needs to solve a problem, needs to solve it in a sustainable way, and needs to solve it in a cost-effective way and make sure that the problem that they set out to solve is solved. So that bit hasn't changed. But everything about how we do that is up for grabs in a way that is changing at a pace that I've not really seen before. So I think, what does it mean today? It means we still need to solve those problems, but that increasingly how we write the actual code becomes a smaller and smaller part of our toolkit, and how we engage with all of these new tools to do that becomes a bigger part.
Who's going to win in this game, and who's going to lose? I'm thinking about myself, old dog. Change is hard for me. It's probably changed for a lot of people in this room. So who's going to win in this game? Is it going to be the young folks coming into it, the middle engineers? I'm hearing stories that they're really struggling with an organization to get that middle bit done, basically. Who's going to win and lose? Dave?
I should confess first that engineering as a term is a bit of a hot button thing for me. I wrote a book on what I think engineering in the context of software ought to mean, and fundamentally that is that we optimize for learning and we optimize to manage complexity in the terms of software engineering. But who's going to win in this new world? I think the people that are able to do that. I don't think that, as you said, I don't think that those fundamentals change. You can think of engineering as kind of the practical application of scientific reasoning to solving practical problems. I think that's a good definition, and I think that's still true. What we're talking about here is a world, a system of genuine complexity. And the way that you navigate in a system of complexity is that you need to iterate really fast, and you need to control the variables, so you need to be able to sense what's going on, you know, to understand what's going on, and you need to respond to what's going on. And I think people who can work like that in small steps, figuring out where they are, trying something out, seeing what happens, and then reacting to that are the people that will win.
What about the key skills that we've held dear to, testing, refactoring?
So I think those are part of establishing that feedback loop, refactoring, testing, understanding where we are after each small change. Those are absolutely fundamental to what we're talking about. I think that the grand plans, the days of waterfall theorizing about what you're going to build, I think that had already been kind of debunked, but I think that's ever more legacy. That's ever more into the distance because the world's too complicated for that to work.
I'm going to skip Rachel for a second, because I know you largely work in smaller teams. Well, there was spoken today about single-person team and five-person teams. Are you sensing that within the enterprise scale that you're working in today, that we're heading towards?
That's good questions. Hi, my name's Will Hamill. I'm head of engineering for digital services at Kainos. I think it really depends on the kind of context that we're working in. Some customers have different appetites, and also we have different abilities to try different things with different customers. I think being able to do more with fewer people sounds like a real cliche and is also absolutely true. You know, slightly less writing the code, slightly more causing the code to be written. but having a view of like what does good look like? How do we know what they're solving the problem in a sustainable way or a maintainable way? And how do you make sure that you've got the right skills within the team? And the skills will change slightly, but like software engineering isn't going away. Even if more of the code goes into abstractions or different tools or things you can delegate to, we still need people who understand how to break down that problem into composable problems that either are already solved, that you can plug together, or that you can cause to be solved, and then putting that together to make the solution. I think you can see that you can do more of that with a smaller team, but you still need the kinds of skills. Like, you know, we don't have typically one developer to one QA, you know, man-marking each other, right? We want developers to write tests, but we want people in the team to have that QA mindset, to be able to understand what quality is and what it looks like. And I think more of those things that in bigger projects will be specialist roles, in smaller scales will be people applying those skills, whether that's a tool that applies those skills or giving people the ability to stretch a little bit beyond as a generalist into those skills.
Rachel, you've spoken in the past about seeing some engineers just park their brains at the door, literally on that arc that we go through when we first engage with the tools and wow, and then suddenly. Well, can you explain a little bit more about your experience?
Yeah, for sure. So I'm Rachel Gawley. I'm a portfolio CTO, so that means I'm across a number of companies. I'm generally next gen before AI, so that could be next generation products, team structures. So it could be a bigger organization, but smaller teams. I think for me, I've been living this in multiple teams, multiple companies for the last years, and watching that erosion of skills scares me because of unchecked AI. So we talked a lot about critical thinking, and just that not being within the loop or testing or specification, you can actually see. So I've seen that live time where something, I think you said it earlier, about this idea of knowing what you wanted to build. And the AI said, yes, that was good. You know, someone checked off with AI, yes, that was good, the test passed, but it wasn't actually what we wanted to build. And that just multiplied that a lot quicker. So I think that, and I'm worried that, you know, I'm loving all these tools, I'm loving the pace that we get, but sometimes it erodes our judgment quicker than ever, and that judgment and the human being. So I think the syntax is solved, code is solved, right? We're there. But the meaning is us, so how do we get back to meaning? Yeah. So I think that's the key point here.
We talked about refactoring and testing, but I think more generally, do you think that software engineering practices that have always been of value to us because of the older way of doing things, what matters in the world that we're about to enter into?
Yeah, I think, and I've sort of been saying this for a while, in small teams, I actually started hiring outside of software engineering, hiring just engineers. I love an engineering mindset, so we're talking mechanical, aerospace, civil, and I think as we go more towards AI, that sort of rigor of, you know, guardrails or this needs to work in a specific way, actually that's what we need with AI because of that sort of non-deterministic and the idea that you're going to ask a question the wrong way and get different answers. So I think an engineering mindset, and it's like, how do we cultivate that?
Yeah, I think we talked a little bit about this when we were preparing for the panel, and people say a lot, AI is not deterministic, as if humans are. Humans are not deterministic. We're just a lot slower than the AI. So for me, those principles of accountability and how do you make sure that you have built the right thing the right way and that it's sustainable, you still are accountable for achieving those outcomes. But in future, will we need code review? Will we run the same structured processes that we do now? I think we have to be open to saying we need to solve these problems, but this shift means that we'll solve those problems in entirely different ways.
I don't know about you, but a big part of being an engineer to me was polishing the stone, kind of knowing when to stop. Dave, you talked a little bit about today that you sense that code quality might not matter as much as it did previously, or human maintainability. Do you think we're there? Do you think code, like for me, still in my head, it matters to me because it always has. Does that mindset need to go? Is that going to shift, do you think?
I think there's a distinction between code quality not mattering and the engineering mattering. So code quality, it depends what you mean by code quality, I suppose. So code quality in terms of our ability to reliably change it when we need to. That's my definition of code quality, is how easy it is to change. I think that remains unchanged. But what that takes might change with the use of AI tools. So I did a toy implementation of something that I was interested in using AI, and I decided that I wanted it to run in Python instead of JavaScript, which the AI had chosen to write it in. So I said, can you change it to Python? And it did, like that. And it still worked. It still passed all my tests. So I was okay. So I didn't really care about the lines of code, but at some level, I care about the structure. You know, I want it to be testable. I want it to be verifiable. I want it to be easy to change. As long as it kind of fulfills those sorts of properties, my measures of quality, then I'm reasonably relaxed about the individual lines and statements. I don't care.
We were talking about this last night, that actually this huge part of programming in my head, and I think
Me too.
grade, is structure.
Yeah.
You know, all those mathematical names that we give to things, packages, etc., they're purely structural things to help us organize. And it's not something we've done particularly well over the years.
So,
not we, but the collective human race.
No, definitely me.
True, but I keep coming back to what feels to me like the closest analogue to this change that I can think of in my, well, not my time, but in time that I'm aware of, which was the step from programming in machine code or assembly language programming to programming in high-level languages. This is more than that change, but it's roughly equivalent. And most of us in this room don't really care about the machine code instructions that are generated at the bottom of the stack as a result of our high-level language usages. I think that the lines of code are going to be the same. That I think we are going to relatively quickly move to the stage where we have that loose relationship. There will be some of us that will care, but most of us won't.
I think what's interesting in that mix on that stack down from where we are, I'm going to say yesterday, we had compilers which were essentially deterministic.
Yes,
today,
absolutely.
The LLM's not a compiler, right? It is a pull the handle and you're going to get something of an approximation.
Absolutely, and I think that's deeply important.
It's a leaky abstraction.
We've got to be able to achieve some level of determinism, which is what my thing this morning was about, is that I think that's a way of achieving some level of determinism at a higher level of abstraction. But we've got to have that, otherwise we're just crossing our fingers and hoping.
Yeah, so outside of producing code, where are you seeing AI bringing both benefits and making things worse in the development pipeline? So, David, you talk a lot about experimentation, but I'll throw the question to Will or Rachel. Where are you seeing it making it better, and where are you seeing it actually making it?
Yeah, I'll go for the worst. I think it's kind of like it's not, because we can do things, the question becomes, should we, right? There's no gates, so it's like, not sure, I'm going to give two car references. The Homer Simpson car, if you've ever seen it, where he just keeps adding features to it, or the Father Ted car, where he just doesn't stop tinkering. And I think that's what AI does. So I think it's that we need to stop more and be like, can I do, just because I can do this, should I? The number of engineers who are like, oh, I don't like how we do project management or tickets, I just vibe coded something to do it. I was like, no, just go again. So there's a lot of that creeping in, and I think we need to encourage that experimentation. But no, like that's not how we work. We're still figuring that out. I'm seeing like really, really great moves with what I would call seasoned engineers who were actually initially resistant and were like, no, let ever craft. But once they get into it, because they were initially resistant, they still have that diligence and checking and that process. So it's like, that's good, but it's like, how do we get like the juniors along the way? I was reading some study recently and they were saying that, we've never, and we saw it in the panel earlier, got more out of our juniors than before, but also we're doing a disservice that if you test the skills, we haven't taught them as much, apart from the use of tooling. So I think it's like, the balance of both.
Yeah, I think it kind of interesting on the other side of that is where, because we know if you ask, for example, go and implement this code, ask an AI tool to generate something, you need to be really strict about what you're asking and what the guardrails are, especially if you're not already, going really hard on specification and TDD from the outset. You'll get it changes these two things, and it also changed two other things while it was at it. Oh, don't worry, by the way, I also refactored these two things. It would be nice while I was doing it. if you saw somebody else doing that, at best, you'd say, look, put that in a different pull request, we'll deal with that separately. But it's so easy for that to fly under the radar, especially if people are dealing with large amounts of pull requests that they might be looking at and saying, looks good to me. You know, how do you prevent it from getting scope creep by mistake? But on the other side, we have you mentioned people like writing their own ticketing systems. Like that's probably a bit far for me, but I've seen that we have some teams where people have been able to build tools that are just problem specific, like to that one team, to that one environment that we're working in, that they wouldn't have had time to build before. Like build this thing that parses all of these data feeds and automatically generates the formats for us instead of having to, you know, manually generate them. And being able to take some of the legwork out of that, that's really just a throwaway task. Like we'll know straight away if it works or not, and we're not gonna productize it, we're not gonna sell it to people, but it takes a whole bunch of time out of that couple of tasks. That's really interesting to see people having the ability to do that they couldn't have done or wouldn't have done because it would have taken days and days before.
I think it's definitely changing the learning game. Engineers now can learn, I think, a lot better and faster. Are you seeing any evidence of impact on cognitive load across your teams? The sheer amount of work that engineers now feel they need to get through and their ability to do so, is it creating cognitive load stress?
I think a bit, there's always a bit of a pressure of like, well, why aren't we getting more out of these tools? And the level of expectation, I think, is completely unlike any other technology. You know, no CEO has ever been asked by their shareholders, like, what are we doing with GraphQL, right? Like, but they're all being asked, what are we doing with AI? Like, why aren't we, you know, doing stuff twice as fast? Or, you know, I read another article in in an in-flight magazine, and I'm looking for new efficiencies. Like the pressure, I think, exists that we need to have an educated opinion on what's realistic, what can you actually expect. It's not a magic wand. And I think in terms of the cognitive load, like when you filter that down, you know, you can't just expect somebody to automatically understand huge amount of context of what it is in a system, what it does. And I think Annie's talk earlier was really interesting about context engineering, and that to me is just another way of describing how to get your requirements specified in a system where you're asking it to implement something. That same type of approach helps you decompose and break things up and set boundaries and set guardrails so that you don't have to have it in your head the whole time. But I do think there's definitely an expectation that like we need to be doing something with this, and I think we also need to have good answers for what that looks like safely rather than just, you know, recklessly.
There's a whole stream we could explore, but we get the time here, about the pressure from above. But engineers love evidence, and they like to take things pragmatically. But there's so much pressure in the room right now to change and to adopt, and how you deal with that sort of from a leadership point of view.
I'm not sure it's a cognitive load, but I sense a justifiable sense of uncertainty and insecurity in people because none of us know what's coming or what's happening, and we don't know what the right answers, more than before, we don't know what the right answers are, I think. I think of the stuff that I talk about as kind of a safety net because that's what's most likely to work in an unsure environment where we are exploring and trying to navigate. So working in small steps and verifying the small steps and all that kind of stuff is what's likely to keep us furthest away from harm. But at the same time that we're asking people to do this, and we're giving these tools, giving access to these tools that can theoretically give 10x improvements in productivity and quality and performance and all these kind of things if the claims are correct. That's a stress in itself. We're also taking away the part of the job that lots of people love. So it's not an easy time for people.
Yeah, I think maybe not so much for me, Tara, cognitive load, but that kind of feeling of burnout, because there are a number of known contributors to burnout in the workplace, and one of them is not feeling in control of what is going on around you. And there is so much change right now that kind of mental load of dealing with the change is quite high. There's an expectation of productivity gains when in fact actually you're almost a little bit slower at the start because you have to get up the learning curve and learn an entire new paradigm of how to do the work. So you do have to put in some time and investment up front before you see the gain. But I think there is from some technical folks, and definitely from a lot of non-technical folks, an unrealistic expectation that you just sprinkle some AI over your deck to the board and magically your business is better.
I thought Shane's point about psychological safety was actually spot on. It's probably more important today than it's ever been for teams to feel safe, to go, look, please, I know we need to change. There's a change management program happening, but we also need to feel safe about critiquing it and feeding that back as well. So we've literally got 5 minutes. I think we could talk for another 40 here, and I've got about 10 questions. Who is accountable when AI engineered systems fail? I'm talking about accountability, not as in who can we blame, which I think is a bad definition of accountability. Accountability is responsibility and evidencing your ownership of a system, through automations, tests, documents, whatever. So who's accountable in AI systems? And I'm thinking not just today, but in the potentially very near future, where more and more of what's output is output by the machines.
It has to be us. It has to be, because otherwise we're just delegating our future to the AIs. It's got to be us.
But can we be accountable in a system where we're reviewing rather than critically thinking? And sorry, I think critical thinking is essential, but there's a danger that we go into, and they're very different things, critical thinking and reviewing.
I don't think reviewing's enough. I think we must be specifying and verifying.
Good.
That's different.
Yeah. That's thinking up front.
Yes.
Yeah, I would agree. I think that you cannot, like in leadership, it's always said you cannot delegate accountability. You can delegate authority to execute on your behalf, but you cannot delegate accountability. And we will need new ways in which to exercise that accountability, but we can't offload it.
Does that not mean that we're sort of so focused on, and this is Michael made this point in his slide, and I think to me it's an important question, we're so focused on speed and, in quotes, productivity, which we're really bad at measuring. Are we not doing so at the expense of quality? Is quality not it's not the main driver here?
It would be really easy to end up there, but it's always been possible to end up there. There's always...
And we always have.
Yeah. I mean, who in this room is not under pressure to deliver more stuff faster and take shortcuts?
Yeah.
To me, that's not different.
We just get there faster with the new tools.
And make a bigger mess.
We just dig the hole deeper and faster.
There's a point you made a bit ago there, Dave, about reviewing isn't enough, and I think it's not just enough, but it's not going to be feasible.
Yes.
And I think it's actually already not feasible today, and we're kind of pretending. And
Yes.
James Matchett gave a great talk earlier about the dependencies that you bring in, like 900 and something libraries for a brand new Next.js app. So I can go to a team and say, like, did you write all the code that went into this? And they'll say, yeah. Like, did you write all the code? Sorry, did you review all the code? Well, you reviewed all the code that you wrote, but you didn't review all the code that went into this. Yeah. It's just not practical. So acknowledging that there is some set of quality bars and checks and other processes involved in, for example, starting a Next.js app with 952 dependencies. We've got static analysis, we've got dependency analysis, we've got all sorts of different checks and tests. And then on the, is it good enough for us? There's specifications and tests we have to write to assert that. I think we need to get to a point where we can find a better way of doing that rigorously and do it about the code that we write, or maybe the code that we cause to be written. Because if you can generate huge amounts of code that's pretty good and pretty correct, you can't scale up just by insisting that you read all of it. So how do you get to a point where you can trust it if you can't read all of it, where we don't actually read all of it today?
I think that's absolutely true. And I think, probably because it aligns with my viewpoints anyway, but I think that calls out for a more structured engineering mindset. Understanding all of those dependencies and the risks that we're taking is the equivalent of a mechanical engineering understanding the tensile strength of a bolt that they're choosing to use. We need that kind of thinking, that kind of mindset, ways of figuring out what the tensile strength of our transitive dependencies are, and that kind of thing, and ways of applying that sort of stuff. We have to get there because the risk's too high.
Is it? I think I'm quoting and trying to figure out on Teams is we need to make the safe path, the easy path.
Yes.
So whatever's easy, you know, at the minute it's too easy now to do a lot of these things. So like, what is our safe path and what is that? And I think we're still figuring out that paradigm. Reviewing's not it. How are we in the mix? How are we setting the bar at the start? And we're sort of realizing that, and that's why burnout is happening. And I think almost introducing a little friction or a little time, you know, is where we need to be heading.
We're just about to run over, but I think a couple of other questions. Was Kent Beck right? Was extreme programming the way forward?
Yes.
Is the software development lifecycle as we know it dead? Basically, are we going to go back to the way it was? Yeah.
No, it's shorter now, surely, right? Because, I mean, Waterfall was never meant to be a one-shot, but nobody read the second page of that guy's paper. Was Winston Royce, is that his name?
Yeah.
It was meant to be, you do this, and then you go, ooh, that wasn't quite what we thought, and then you do it again. But nobody ever scrolled down past, you know, that classic waterfall diagram. So if iteration is faster, then you've no excuse not to build something faster and use some of the time saved to say, was this really what we wanted, or is it being used in the way that we thought it was going to be used, or like is it good enough, you know, to scale? So the more that you can get your cycle time down faster, like none of the parts of design or understanding go away. They just potentially become skills that fewer people use rather than independent people. And the cycle time being faster means you can take that advantage to say, well, now we can give it iteration 2, we can give it iteration 3.
So the cycle times need to come down, and we need to automate more, we need to be able to release more frequently. But that is not a practice that is done today well by the majority of
I just like to say I know a couple of good books.
But also we need to remember, right, that we can ship it as fast as we want. At the other end, some poor CIO was running all of the digital transformation programs for people to actually be able to benefit and use from these systems. And the piece of writing and testing and shipping the software is in itself a very small part of the value chain of actually delivering business benefit end to end.
Yeah.
And to be fair, never was. It's just more obvious now that the AI can kind of write code like that. But the rest of the cost is still there, and so we've got to make the verification keep up with the rate at which we can produce code.
We're way over time now, so some final thoughts, folks. Is it time to be worried or time to be extremely excited about the future?
I think you can't be excited without being a little bit scared. So I vote excitement, but excitement comes with fear.
Yeah, I'm against my normal nature, I am trying to be optimistic about this because I think it's too easy to be frightened. But I think if you're not frightened a bit, you don't understand the problem.
I'm naturally optimistic, and I'm always like, bring it on. And if I'm saying slow it down, that's an interesting take from me. But so I'm optimistic, but I think we just need to slow down things, figure out the friction, and start asking, should we, rather than just, can we do it? Sure, why not?
Yeah, I think it's like AI isn't the second coming, right? It's a way of getting better at what we want to do. You might write somewhat less code, but software engineering isn't going away. It's still about building what works and doing it in a way that we know is going to meet the needs of the people we're building it for.
Thank you. And thank you, everyone. That was a great panel discussion. Please put your hands together, folks.